Welcome back, everyone. Hope you're ready to start really playing with pattern blocks and to get our heads around how those could be used for fractions. So if you don't have pattern blocks in front of you, but you do have access to them in the school, I'm going to suggest you just pause the video right now and go grab them, because there will be no better way to really learn these than to do them alongside. So feel free to pause at this point and then come on back. Great. For those of you that are joining me, I'm going to just ask you to go into your bins and pull out one of every block that you see there. So there should be the yellow one, the blue one, a green one, an orange one, a red one, and sort of a buff colored one if you want to get those out. And you're going to see lots of parallels here between what we did in Cuisenaire rods and actually what's going to show up here. Very similar. So it'd be good to have students actually have those at some point side by side so that they can see how those connect and what you would do with those together. All right, so here's my task for you to start with. Just like we did in Cuisenaire rods, we started with an orange rod. We're going to start with this yellow. And I'm going to ask you, you can get as many yellows out as you're going to need, but I'd like you to find me anything that fits on top of the yellow hexagon. Nothing, no holes, nothing not fitting tightly, nothing hanging over. It's got to be a clean fit. Doesn't matter what color it is. So I want you just to go through and build all of those, and then we'll have a conversation about those. All right, while you were building, so was I. So I went through and kind of did my own combinations here of everything that could cover on top of a yellow. You might have them in slightly different orders. Doesn't matter. I'm hoping that some of these don't turn out to be too dark, but one of the things I wanted you to have an opportunity to find out was, you probably saw that that buff colored rhombus and the orange square just don't fit. There's no way to get them on top of that hexagon without having a hole somewhere. There just is no other way to put these guys in there with any of those shapes. So we wouldn't tell that to students. We would want them to explore that and find that out, because that is in fact true. We're not using those when we talk about fractions. Those guys are gone. So we're only dealing with basically the blue rhombus, the green triangle, the red trapezoid, and the yellow hexagon. So those are going to be our shapes that we're going to deal with for now. So now that you kind of see how they fit on there, and again, the way I have mine ordered doesn't mean that they have to be identical on yours, and you might even have come up with something that's completely different. I'm not sure there's a whole lot more combinations, but what I wanted to go through now is have a look and see if we talk about in the Cuisenaire rods. We built an orange rod the very first time. We built an orange and we said, build anything with any color on it, any amount. So that's exactly what you're seeing here. No restrictions, just cover the yellow, no go gapping holes or anything like that. So now what I want to do though, is I want to look at, let's look at the ones where the color is the same. So I'm going to slide some of mine out of the way here just for a second. And the color is the same on these three. And so we would ask students, first of all, make sure that they know the names of the shapes, because that would be helpful, and they probably did patterns already. So the trapezoids, how many trapezoids did it take to make one hexagon? It took 2. Okay. How many triangles did it take to make a layer over top of our hexagon? It takes 6. How many blue rhombi do I need in order to make one layer on top of the yellow, in this case 3? So one of the things that you could do at this point, and you could even pause the video if you wanted to just do it on a piece of paper, take one of each of these shapes, the hexagon, the trapezoid, the rhombus, and the triangle, and just trace around them on a piece of paper and put them in vertical order. So if I was doing them on my sheet of paper, my paper would look like this, kind of in this order. Okay, and not too close together. I just usually have the kids trace it. Because what we're going to do now is ask them to think of what portion of this whole, this hexagon, did that color cover. Okay, so if they've traced around it, then we can say on the side, we could write beside it whole. This is the whole. I had to cover the hexagon. I had to create an orange rod, a blue rod, whatever. Those were our holes. Doesn't matter what the number is. It doesn't matter what it reflects. We just want to know the relationship between these different blocks to that. Okay, remember that's how we defined a fraction there. It's a relationship. We are not in any rush to write any numbers down here at all. So then what is the red related to the yellow? How many reds did I need to cover the yellow? Well, it took 2. So that means that each one of those reflects 1/2 of my hexagon. So a red is 1/2 of the hexagon. And they could write that down beside it. It took 1 out of 2 red pieces in order for me to build that hexagon. So then how will I write the blue and how will I write the green? So again, we want them to go through, have a look at it, not just giving them the answers and saying, well, here it is. This is what the value is. Let's let them figure that out a little bit. So again, moving ahead, we've got 1, 2, 3. So each one of these blues is 1/3 of my hexagon. And the greens, I needed 6 of them. So this one little triangle, when I'm talking about this being the whole, is 1/6. Okay, that's foundational pieces for fractions when we use pattern blocks. They need to know that. But the important piece is that they need to know we started with this, because I don't always have to work with that. It limits me in some respects. So we want them to be really fluent with showing all the different combinations that they can. So now my next question would be, if they have these on a piece of paper, I'm just going to move mine to the side here again. What blocks can build a trapezoid? So just like we built this layer here, I put one down here and I'll get them started. For example, I might say to them, I could put a blue one on here, and then what else do I need to put on there, right? So have them put as many as they need on the side and have them build what are the layers that they can create that would give them a trapezoid. And do the same thing for the rhombus and do the same thing for the triangle. All right, I'm back and I built mine as well. So you can see, well, first of all, you can see I've got different shades of green, but you can see that when I do the trapezoid, I could put a rhombus, but then the only place I have left is for a triangle. Or I can put 3 triangles on it. And if we ask them, does that make sense to say that that would be correct, 3 triangles? Remember when we said how many green triangles covered a whole? We said 6. This was 1/2 of the whole. This is how many? 3. 3 and 3 is 6. So yeah, makes total sense, right? But those are connections we need to have conversations about. Don't just assume that intuitively they're going to figure that out. So going back and just deliberately making those connections back and forth. A lot of times when you do questions with them here, you're going to ask them, why? Why again, is that right? So they should be able to back it up by doing things like this, saying that, well, if a red is 1/2 and it takes 6 to fill, then 3 is correct, right? That's the rationale we want to hear, not just assume they know. The rhombus, well, I don't have any choices there, only 2 triangles. That's all I have really that fit on top of there. And again, how many rhombus fit on here? 3. How many green triangles? 6. How many green triangles on one rhombus? 2. 3 times 2 is 6. Okay, so again, we can get them to think in those terms. Triangle? Well, there wasn't anything else. There really is nothing else that I can do on there. So it was by itself. Okay, what I'd like to do now is clear off your blocks, put them into kind of a pile. I'll do the same and then I'll come right back again. All right, so I'm back again. So now what we're going to do is we're going to fast forward again. We're not in a rush to always just show them the algorithm. So now the question will be, and I've got mine showing already, but we would want them to build it first. We would ask them to show 1/3 of the hexagon. So that means I'm going to put one rhombus on top of my hexagon. And we'd ask, what else could represent the same amount over my hexagon? Well, there's only one option there, and that would be to have 2 green triangles. So 2 green triangles is the same as 1 rhombus, and on top of our whole, this is 1/3. This represents 2/6. So where am I going? You can see that 2/6 is the same as 1/3. So we can start that process of talking about equivalent fractions. If they've already done Cuisenaire rods, then they're going to start to recognize that really quickly. They'll say that's equivalent fractions. So they'll get that sense right off the bat. So then over here I had put a trapezoid underneath, and my question is, what's equivalent to the trapezoid? Well, if the trapezoid is 1/2 of the hexagon, I can put 3 rectangles on top. So 3 out of 6 is the same as 1/2. And then over here is my open question. Here I have 2 blue rhombus, so 1/3, 2/3. Find something that's equivalent to 2/3. And they may say, well, I'm going to put a trapezoid across here and then something else. But remember, to be equivalent, they have to be the same color. So that won't work. It's not that it won't fit, it's just not going to be the same color. So in this case, again, the only thing I can do is just put 2 triangles on top of each one of these. So 2/3 is the same as 1, 2, 3, 4 green triangles, or 4/6. Right? That's really, really important for them to see that equivalent piece, because that's going to be foundational to when we start doing addition of fractions again. So that's the kind of connection that we want for them, and they should be able to do all kinds of different shapes, right? Those are the pieces that we want them to be fast at, not slow at. Okay, I'm going to take mine apart really quickly. You can do the same so that you can just find them as needed. And I'm just going to bring out one of our sheets. Well, actually, let's do one step first. Take some yellow hexagons. And can you show me what unit fractions could be represented for a hexagon? Now, remember, to be a unit fraction, it must be the same color that covers the whole layer. So we've already talked about it. It's not going to be new. It's could be even just a review piece, but show me on each one of these what the unit fractions would be. So I'll get you started. There's 1, 1/2. There's 1, 1/3. And there's 1, 1/6. Okay, we don't have any others that fit onto the hexagon. So 1/2, 1/3, 1/6. These are the foundational unit fractions. And remember, when we're on a number line, they've got to be able to count by 1/6. So that as they make a count by 1/6, they're adding another triangle, and that takes them to the whole, or 1. Here they're counting by 1/3, 2/3, 3/3. 3/3 gives me the whole, but they would do that on a number line at the same time as they're putting it on here, because the importance of seeing numbers, fractions on a number line, to make sure that students connect it to being a number system as well. Okay, and that's really rather critical, because these also are the foundational pieces then to finding our equivalent fractions. So we really want to make sure that they're strong in finding those. And these are pretty easy, and they do like these, and they remember them really quickly, so it's not a big part for them. Okay, so I'm going to put together a simple addition sentence. What do I want to do here? I'm going to go maybe I'll do the same. I'll do the 1/6 plus 1/3. Okay. So I could put those on the board. If you're doing them there, you could just simply say, show me 1/6, show me 1/3, put them on your paper. We're going to put a plus sign in between. And so now we want to add them. And so it's going to be as simple as thinking in terms of, just like when we did rods, they have to be the same size and the same shape or lengths before I can start finding equivalents. So same thing here. I can't just add a triangle to a rhombus and come up with a new color and a new shape. It either has to be all rhombus or all triangle. So can I change the triangle into a rhombus? No. Can I change the rhombus into a triangle? Yes, I can do that by replacing it with 2 triangles. Now I have the same shape. So 1/6 plus 1/3 is the same thing as saying 1, 2, 3, 6, because the triangles are 6. And if that's true, I move them all onto 1, 3, 6, correct. And could we replace three of these triangles with a single block? The answer is yes, we could. 3 6 1/2. So 1/6 plus 1/3. Only way I can do is change it to the same color, find a same color. In this case, it was green. I add them together. And when I add them together, I ended up with 3 out of 6, which is exactly the same thing as a trapezoid. So initially, they're just going to be swapping shapes and sizes that match. The number part comes along with it, but it doesn't necessarily mean that that's going to be the piece that's going to be their starting point. Okay, show me 1/2. And show me 2/3. Let's do 2 of these rhombi. Okay, so now I have 1/2 and I have 2/3. So now, again, I want you to add them together. So before I start doing it, I want you to go ahead. Remember, I can't add blue to red. I have to have the same color in order for me to do this. So what color am I going to have to find that's going to fit? Well, what shape do they have in common that you can convert them both into? And go ahead and do that. So I took my red trapezoid and I already changed it into my 3. And eventually what they'll say is, I don't really need to put it on there because I can already picture it. And that's awesome. That would be where we want to go. Okay. So I have 3 triangles to replace my trapezoid. I have 4 triangles that replace the 2 rhombi. So the question now is, when I add these together, that means I want to put them all onto 1. Something's going to happen here. I'm going to end up with, when I take 1, 2 of these over, that's great, except I still have 1 left over. So in this case, I filled a whole 1, so I have 1, and I still have 1/6 left over. So my answer is 1 and 1/6. Why? Because that gave me 7/6. It was an improper fraction. So we don't have to go to improper fraction right away. We don't have to say to them 7/6 is the same as 6 goes into 7 once with 1 left over. That'll all come. It'll all come. It just doesn't have to happen right off the bat. So let them get these kinds of questions over and over and over again. And then eventually we can show them that, you know, there is another way to do this algebraically. As they're starting to get good at this, we would have them be writing this out on a piece of paper at the same time and showing what they're getting. So I wouldn't be saying common denominator, but I would say, what did you do here? You went 1/2 plus 2/3. That was my starting question. You changed it to 3 6 plus 4 6 as my next step. My final step over here was 7/6 when I counted them, and my answer was 1 and 1/6 when I was done. I had 1 whole and 1/6, and we would show them how to write that. Okay, get the idea of how that's working. So these foundational pieces, these unit fractions, are absolutely critical for the students to remember, and they learn them very, very quickly. It's not like something we have to, get stalled over or anything like that. So I'm just going to make the parallels for you so that we can have the Cuisenaire rods at the same time. I know the white's hard to see, but here's our orange rod. It was 10 long. And we said, what are all the different layers, just like you did with the blocks just now, that we can make on an orange? I could use 10 whites, I could use 5 reds, I could use 2 yellows. So this became the 1/2 unit fraction, this is the 1/5, and this was the 1/10. And the reason we needed to know those kinds of things is because then we introduced to them how we would do equivalent fractions, and invariably what you're finding is the common denominator or the common color, just like we just did. I need a common color before I can do something. So remember, this was my example of 16. In Braining Camp, we can enlarge any rod we want and just call it. So it's a pink color. It's not one that you'd have in your kit. So I made a 16. And then we asked, what are the layers that are the same color that you can build underneath? So 2 browns. I could have my 4 purples. I can have 8 reds because they're each 2, or I can have 16 whites. So if I had said to a student, what is 1/2 plus 1/4? What I do is I run my finger and my pen down these vertical lines where the rod ends. And when I hit a row of color that they both hit at the same time in a vertical line, which happens to be right here, I don't even have to move on the purple one. I can come right down. It lines right up. This one lines right up. So 1 brown is the same as 2 purples and 1 purple. So I have 1/4 plus 2/4, and the answer would be 3/4. But now I could say, what other colors could they be? Well, 3/4 is the same as X number of reds. 3/4 is the same as X number of whites, right? So it's that simple slide up and down of those fraction bars that we use. But really, it's the slide up and down. What you're showing them is how to find the common color. Common color is the common denominator. So when we introduce the process of common denominator, we say to them, remember when we found the common color? Remember that's how we did it, and then we were able to add them together? Well, that's because they were the same shape, the same size. Okay, so there's a problem though. You can see we're pretty limited here. We've only got 1/2, 1/3, 1/6. That's not a lot of choices. So let's introduce the other member of the family. Now, you might say, no, I don't have those in my box. Depends on if your school, when they ordered them. Because when they first came out in the 90s, the first boxes all had just what you were working on. And then we found that because it limited the number of fractions that we could actually do with students, it kind of looks like a happy face. What they did then is they created a new base. Now, if you don't have them, I'm going to use these. This is called the double hexagon, and this is called the chevron. I'll turn it over because for some of you, depending on your age, remember going to gas stations that had that chevron symbol. That's where it got its name. Now, if you don't have it, this is your double helix right here. It's just 2 yellows. So you can pretend that you have a pink and just use 2 yellows. And this guy is just 2 of these blue rhombus put at an angle like that. All right. So if you don't have them, that's going to be how you're going to build your things. So why do I want those? Well, because now I'm going to say, this is my whole. So what I would do is have them trace. If you don't have it, just trace 2 of them. And then again, we're going to line them up. All those pieces that we had, doesn't matter what order you put them in, I'll try and keep them somewhat the same. Okay, I'm going to run off my screen here because I have a limited amount of space. Okay, I'll push mine together. Okay, the triangle's at the very bottom here, you guys. So what I'd like you to do is once they've traced them, now we're going to write whole beside this one. Now, what have these become? Because now this isn't the whole anymore. So it's going to have a new meaning, and all of these are going to get a new value. So again, go ahead and fill in all the layers that you can. Find out how many times these pieces fit into the pink. And then I'll come back, I'll build the same thing that you are. All right, so things changed, didn't they? You got lots more options now that we're going to end up with when we start talking about fractions. So now when they fill in that chart that you gave them, the yellow is now 1/2. So the hexagon is 1/2 of the double helix. The reds that used to be a half are now 1, 2, 3, 4, 1/4. The black is 1, 2, 3. I have to turn them somewhat sideways, but 3 chevrons will fit on top. So each one is 1/3. The chevron was made up of 2 of the blues. So now instead of being 1/3, the blue rhombus is 1/6 because it takes 1, 2, 3, 4, 5, 6 of those to cover my pink. And these little guys, I need 6 for each one, so I now have 12s. So you can also see that as soon as you put the chevrons and the double helix in here, you are going to start getting shortages of the greens, depending on what kind of questions you give them. So I often start that first piece that we did so that they're doing it individually at their desk. And then once you start moving into the bigger ones, depending on how many blocks you have, if you've got lots, not an issue. But if there's a question mark about how many they might need, then just have them work in pairs because they don't all have to have exactly the same amount sitting on top of here because you'll run out of greens really, really quickly. All right, so that gives you an idea. So what do I have now? Now I've got 1/12, I've got 1/6, 1/3, 1/4, and 1/2. And I still could have used some of the other pieces, but right now let's just stick with the double helix because it gives us more opportunities. So as I'm working with those different shapes now, I can ask the same kinds of questions. Like, for example, can you show me, I'm just going to take some of mine apart so we have room to see here. Can you show me, and you can do it on yours, 1/3 plus 1/4. So 1/3 plus 1/4. So this is my whole. And I'm going to add 1/3 and 1/4. Okay, rules are still the same though. Can I add a black to a red? No, there's no colors that I can mix up that are going to come up with that. Shapes don't look the same. So I need to find a common shape and a common color that would both work. So some students will say, well, the blues will work. Yep, the blues work on the black. One blue works on the red, but not going to go in there evenly. So we're back down to looking at the triangles. So I'm going to have 3 triangles over here, and I'm going to have 4 triangles over there. So 1/3 is going to be the same as 4 12s because it takes 12 the greens to cover this pink. So this 1/3 will be the same as 4 triangles sitting on top of it. The red is the same as 3 triangles on top of it, or 3 out of the total 12 that could cover this. So when I add my 4 over here together to this 3 over here, I will end up with a grand total of 7 over 12. And in interest of time right now, I would have the students do that. It's important they see it. So they're going to see that they're going to fill half of their double hexagon, and then they'll have 1 extra one. So 6 plus 1 is 7. So they see that they haven't filled the whole thing. But the importance is that they're able to find the color combinations that need to happen. Okay, what if I change the question to say, I can just leave these guys on here, 1/3 minus 1/4. Okay, because we were doing addition, let's do a subtraction one. We've got them laying here, so might as well use them. So 1/3, same rules apply for subtraction. I have to have the same color and same shape. So again, we already have concluded that it has to be a triangle. There will be 3 here and 4 here. So if I have 4 out of 12, take away 3 out of 12, that would leave me with 1 out of 12. So 1/12 would be my answer. So it's not a difficult piece for them, but it's important for them to see. So having them build some of those relationship sheets where they can see them, you're not going to finish all this in one day anyway. You're going to be coming back to it over and over and over again. So having them fill in that kind of a sheet like this, where they have the different shapes and how many of these built that whole. And I'm going to say to you right off the bat, there's all of the pattern kits that you have. I would be shocked if your school doesn't have binders. This comes out of one of the binders that's there. They have excellent support resources that you can give students. You will never do them all, and nor would you do them all. You can pick and choose the areas that you're working on, things that you find that they need a little bit more review in. But this is the kind of progressional piece that you might want to use with them and that they could have in their books that they can always refer to. And I also want to say to you that just because we started and went to here and said, you know, here's our new whole, well, I'd be pretty quick to say to the kids, oh, well, actually, this is our new whole. Right? Once I get the idea of how this is going to work, I can put two together and say, that's our whole. Now, what's this going to be? What's this going to be? What's this going to be? So that it really gets me to realize whether or not they're understanding that it is determined by the whole. The value of the shape will be determined by the whole. You can change it to whatever you want. You could even take a pink and put one of these in, and they kind of like that challenge, right? They, oh, that's our new whole. All right, so what does that make? So if I need different kinds of fractions, then they see that too. They'll see different values of fractions showing up. So you're not labeling and only stuck to what this is. And that's important for students to know, is that we can be flexible in our thinking. Once we understand the process, there is nothing stopping me from changing the values. But I might even use a question like this, where I say, here's 3 wholes. And on this one, I'm going to put 5/6. On this one, I'm putting 2/3. And on this one, I'm putting 3/4. Which one is greater, right? That comparative conversation. Which is the greatest fraction? Which is the least fraction? Which is the smallest one? If they can't picture it already, then they can lay it out. So 5/6, 2/3, 3/4. And then you tell me which one is in order from largest to smallest to largest. So again, it gives them a tool in which they're able to go in and do that comparative language conversation. And we often just assume that once we've taught them a common denominator, that's a no-brainer, like they've got that. And that could be further from the truth. Like that's not always intuitive for a child just to make that big leap in that connection. I'm just going to show you, we won't go through and do them, but I do want to show you some of the things that are available to you so that you know that you don't have to recreate the wheel for everything. In these resources that come with it, they're binders. So they'll have adding fractions, and there'll be pages and pages and pages. And that's why I say you're not going to do them all. But once I've done that kind of hands-on work, I would give them a question sheet like this, but with the tiles beside them. I'm not assuming that they're just going to jump into this. Now, you're going to have some high flyers who already are there and don't need the tiles. But remember, we still want to be able to ask them to explain their thinking. So they should know how to demonstrate it. But here, what they're asking them to do is based on the picture using the double hexagons. What's shaded in? When you add that fraction together, how are you going to make, what do you need to make into the same shape or same color? So that's for having them beside them so that they can actually do both of them, make whatever switches they want so that they can write the fraction down that's equivalent, and then they can get their answer that's here. These are great. I mean, this is the kind of thing we want. And there is no rush to say, oh, well, you know what you could have done is you just could have multiplied the top and bottom of a half by 2 and got 2/4. And yeah, we will get there. We just don't have to get there all in one day, and nor do we have to get there even in the first couple of days. The reason is the slower we go now for them to understand, the faster you can go later when you want to do that algorithm. If I get it in my head and I can close my eyes and picture these blocks being moved around without me actually having to use them if I didn't want them, is way better than me just trying to remember what the rule was. So again, they start off even in incremental, right? Here's some 12s. I'm going to have to change that one to 12s. So they start small and they work their way through. But again, I wouldn't even do all the questions on a page. I might just say, you know, I've got 2 of you, I want you to work on 11, 12. I've got a couple of you want 13, 14. I've got a couple of you that are going to take the more tougher ones. Whatever. It doesn't have to be everybody doing everything. All right. So let's move on. Make it my helix back here again. Bridge. And I'm just going to grab a marker here. And if I said to you, let's move into multiplication. Some of you are probably saying, let's not. Okay, we got this. All right, so when we give them a multiplication, and we can absolutely do this with pattern blocks, you have to teach them how to read it too, so that they have a sense of the reading and understanding of this will really hinge on what it is I'm actually going to do here. All right, this is my whole, right? I'm always referring to the whole. So that will be really important for the students to understand, is you're always going to refer to the whole. So if I say I want 1/2 of 2/3 of a whole, right? That's really what this is saying. I can go 1/2 times 2/3 means 1/2 of 2/3 of a whole. Now you could flip it around. You can say you want 2/3 of 1/2, but let's just, I don't care. We can do both. Doesn't matter to me. Now, typically what people will say is top numbers times top number, bottom times bottom number, and then reduce if you can, right? Great algorithm, not wrong, but there's no understanding to that, what that's actually asking them to do. So let's put up 2/3 of the whole. So show me 2/3. Well, we know how to do that. That's 2 chevrons. Okay. There's my 2/3. So now they can actually see it. I see 2/3 of the whole, and I would like 1/2 of that. I would like to know what 1/2 of these two pieces are. Well, that's an easy one. It's one of these. And what was one of these on a pink? 1/3. So we took 1/2 of the two pieces that were left on there. Of the 2/3 of the whole, we wanted 1/2 of it. So I only needed to take one of them away. So that makes it fairly easy for me to do. In a normal world of algorithms, we would have gone 1 times 2 and 2 times 3. So 2/6. And then we would have said, can you reduce that to 1/3? Yes, we can. Some of you also, and I'll go that one step further as well. Some of you teach the students to always look for common factors on top when you're multiplying and on the bottom. So I could have said 2 divides into 2 once, and then I get 1 times 1 on top, 1 times 3 on the bottom. When we do it this way, they get reduced fractions automatically in their answer. Okay, so remember I said we could have, if it made more sense to you, and some of you might have said, I think I see it better the other way. I'm going to turn my board around here. Let's take the same question, and let's say it was 1/2 times 2/3. That was our question. So what if I say this time I want to read it differently? So I'll rewrite it so that we're saying it the same way and it's consistent for you as well. This time I want 2/3 of 1/2 of the whole. Okay, I want 2/3 of 1/2 of the whole. All right, well, first of all, I have to show 1/2. I always get them to build whatever it is we're working up of the whole. So 1/2 of a pink is a yellow. Okay. And I want 2/3 of this. 2/3 of that. 2/3, think back to your yellows, was 2 blues. A yellow was 2 blues, gave me 2/3. Okay, put it on there, right? Would help. Okay, but you get the drift. Could have used a chevron too. It's just I wanted to make sure that everybody sees the 2/3 there. And again, 2/3 of the whole thing means that I would be talking about, let's say 2 triangles here, 2 triangles here, out of a total of 12 triangles, if that makes more sense to them, to basically take that. Okay, so I want 1/2 of that amount, 1/2 of what I see here. So it would be exactly the same thing. If I'm going to take 1/2 of that, I would end up with 4/12 when I count these out, which is the same as 1/3. So the order won't matter. Okay, so that piece is the same. All right, let's try another one. I'm going to grab another whiteboard here. I think I have one. Maybe I don't. Okay, I'll just turn it sideways. let's try, okay, another pink out. And let's do, I want to take a smaller number. I'm going to show you some sheets that you can use if you want, but I want to just take a smaller number. Let's try, yeah, let's do a 1/3 here. Put this in here. Okay, so our question is 3/4 times 1/3. And I know some of you are already dividing in your head and you know what that's going to look like. So I could build the 1/3 of my whole. There's my 1/3. And I would like 3/4 of this. So that means I need to be able to see quarters in this. So what can I do to build that I can see smaller chunks in this? Well, we know that we can put triangles on top. Put them on this time so we can see them. Okay. And we would like to have 3/4. In other words, we're going to take 3 of the 4 pieces that are there. Because this is 1, 2, 3, 4, and I want only 3 of the 4. Okay, so it's like saying I'm going to take that amount. So I want 3/4. So I end up with 3 12s. Why did I get 12s? Because remember, to make greens, there are 12 greens in a pink. I only wanted 3/4 of the piece that was on there, but it's always related to the whole. So I have 1, 2, 3 out of 4 pieces. There's my 3/4. And the greens make up 12 in total. So that means I ended up with 3/12 or 1/4. And if that's true, then when I had put that trapezoid on top, is that 1/4 of a pink? Yes, because it takes 4 trapezoids, 1/4 each, to make the pink. Multiplication and division take just a little bit of practice. And it's not that we can't do it. It just means that we have to read it and give them guidance to build one portion first. And then read it so that I want that amount of the portion you built. Okay, I don't want to always go, it's not 2 values, not 2 wholes that we're going to put down here. It's always just 1 whole. And I'm going to just back up a bit, and my apologies, but I want to just say we probably, when I think about the new curriculum, grade 3, grade 4, would have covered a question like, what is 1/2 times 2? Right? We would have started with the whole number first, and I might have jumped the gun there a little bit. So what would that look like? Well, I always think initially when you show them, just show them as like repeated addition. What's 1/2? 2 sets of them. There's 2 sets of 1/2. So you're saying 1/2 twice, 1/2 twice. What do I get? I get 2 out of 2 or a whole. Is what you would get if you multiplied, right? Top number times top, or if you canceled. Let's try another one. What if I got, let's do 1/4 times 3. Let's bring another one in here. So 1/4 times 3, because they always start with a whole number first. So there's my 3/4, 3 times, which gives me 1/2 there and 1/4 left over. So I have 1, 2, 3/4. Instead of just saying multiply the top number by whatever you have and then just getting that, this way they can show it to us as they move along. This is also the same thing as skip counting by the unit fraction on the number line. And that tells them how they get to each of those values, exactly what we did with finding unit fractions with money, finding unit fractions with Cuisenaire rods. All of these blocks, all of these manipulatives in a lot of ways tie together. So it's really, really important that we make sure that students understand that those pieces are not unique. It's not that I would only use pattern blocks to do fractions. I would only use Cuisenaire rods to add numbers together. They're all interchangeable. I can add numbers together with all kinds of things. This just lends itself easier to fractions. But could I add numbers? Sure, I could. I mean, it's not impossible, that's for sure. Okay, let's see. Is there anything that we have missed here? I think we have covered it all. So again, when it comes to multiplying, you can do any of those from the resources that are in the book as well. It's not just what I'm showing you here. There's lots of little ones that we can do bits and pieces of. If you are doing some of these and you want some extra questions, or you're looking for some background again on this, don't hesitate to reach out either to somebody in your own consortia or to just email me directly, and we'll connect and get that sorted out. So hopefully that gives you a starting point for the pattern blocks. Now I have one question to leave with you. For those of you that are going to be joining me for the second part of this, where we do what's called the deci blocks, as there are some other blocks on here. So you've seen all kinds of fractions now. You've seen quarters and thirds and 6 and 12s and halves. So what I would like you to do is with all the different shapes, and if you don't have this, just pretend you use 2 yellows to make one if you need it. I'm not saying you do. I would like you to create a shape for me that would give us the possibility of tenths. Okay, so you can use any of the shapes that we had from before, anything, right? Any of those ones, or this one, or the chevron, or whatever. Is there something that you could put together that would give me a tenth, so that I would have that fraction to work with as well? Okay, that's your challenge before you come back and meet me in part 2. Thanks, everyone.